Greetings, judge, teachers, and friends. We are the competition team from SMJK Convent. Me, Emily, and my teammates, Wei Jia, Hui Qi, Jia Hui, and Shi Hui, will be presenting our invention, which is a cooling flask named CryoFlask. This is the content that we'll be presenting today. There's a total of 7 parts.
I'm Chui Chi and I'll be presenting our problem statement. Our problem statement is, how do we produce a flask that can maintain cold temperature of beverages for an extended period of time without using energy or refrigeration?
My name is Emily and I will present about the objective that we make the product. Firstly, we hope to produce a thermal flask with affordable, eco-friendly and made by recycled materials, which is polystyrene bins, aluminum foil and also plastic container. We also hope to produce a thermal flask which can maintain a low temperature for extended time. And it is portable and needs no refrigeration, so that user can use our product anywhere and anytime.
Thanks to my fellow friends and the judges. I'm Li Weijia and now I'm going to present about the methodology of our product, CryoFlask. Firstly, I'm going to present about the materials we have used in this product. The chemical used is the ammonium chloride, and the materials of our CryoFlask are 3 different sizes of plastic bottles: clay polymer, polystyrene beads, polystyrene sheet, Ziploc bag, aluminum foil, and a knitted bottle warmer. And the apparatus we have used are the 100 ml measuring cylinder, electronic balance, thermometer, and spatula. Next, I'm going to talk about the procedure that we have done to make this product. First, the frame of the CryoFlask is made by inserting 3 different sizes of plastic bottles into one and another. The outer layer of the plastic bottle and its cover is wrapped with aluminum foil. And then a polystyrene foam sheet is inserted into the gap between the outermost plastic bottle and the middle plastic bottle of the CryoFlask. Then the gap between the second plastic bottle and the innermost plastic bottle is filled with polystyrene beads and sealed with clay polymer. We then measure 45 grams of ammonium chloride salt using an electronic balance and 100 ml of water measured using a measuring cylinder. Then 2 ingredients are mixed into a Ziploc bag and we shake it until the chemical dissolves. And then we put the Ziploc bag into the inner layer of the CryoFlask and we put together with your bottle of beverage. And then we put the CryoFlask into the knitted pouch and now it's portable. You could bring it anywhere you want it. This is a picture showing us adding polystyrene beads into the gap and sealing the polystyrene layer with clay polymer. Besides that, we also experimented to find the best ratio for the mixture of ammonium chloride and water that maintained the temperature of the cold water for the longest period. We also experimented to find out the difference of the temperature of cold water with CryoFlask and without CryoFlask in room temperature. The data is recorded and will be shown to you by the next presenter. And lastly, I'll be presenting you our final product of CryoFlask. As you can see, there are a few insulation materials in the CryoFlask. There is the aluminum foil and the polystyrene beads. And there's also different layers of insulation materials. We also have a neatly knitted pouch that you could put your CryoFlask in, and it's now portable, and you could bring it anywhere you want.
Hi everyone, I'm Chong Shi Hui, and now I'm going to present the data collected from our experiment. Ammonium chloride has the best cooling effect, so we use it in our experiment to get the optimum ratios of salt to the water to get the optimum drop in temperature. We took 3 tries in our experiment to get the actual data. Let's see the table. From the previous slide to this one, we know that the higher the amount of ammonium chloride added, the greater the temperature drops. Adding 18 grams of ammonium chloride to 40 ml of water can reduce the temperatures of water by 18 degrees Celsius. It is our best cooling effect, so we decided to use this data to calculate our ratios of salt to water, and we got that 45 grams of ammonium chloride is needed when the water filled in is 100 ml. Next, we experimented to find out the time taken for the temperatures to drop with and without using the CryoFlask. The actual data is written in this table to compare their drops in temperatures. We start at 7 degrees Celsius. Let's see the table. CryoFlask use polystyrene beads, which are good heat insulator, and aluminum foil that can reflect heat from outside. Therefore, as you can see from the graph, the rise of temperatures with using CryoFlask is lower compared to without using CryoFlask. So it means that our CryoFlask is effective to keep water cold.
Discussion. So, how does our CryoFlask work? Firstly, the chemical we've added is the ammonium chloride, which will be activated by water. An endothermic reaction will then occur, absorbing all the heat from the surrounding. And with all the insulating materials we've added, for example, aluminum foil and polystyrene beads, can help to reduce heat transfer. Next, how effective is our CryoFlask? Based on the previous results, it is shown that the temperature of water using CryoFlask has only increased by 6.5 degrees Celsius in 60 minutes, while the temperature of water without using CryoFlask has already increased by 20 degrees Celsius in 60 minutes too. Therefore, it is proven that the temperature of water using CryoFlask is lower compared to the one without using our CryoFlask. For conclusion, our CryoFlask keeps water cold. It allows the water temperature to increase by only 6.5 degrees Celsius compared to 20 degrees Celsius in 60 minutes. It is effective in reducing rise in temperature of cold water by 3 times.
And now, I would like to introduce the significance of our CryoFlask to you all. So, what is the significance of using CryoFlask? First of all, it is suitable for people from all walks of life, which means that either children or elders, all of them can use our product. CryoFlask is also portable and eco-friendly as it is made from reusable materials, and this reduces negative impact to the environment. Besides, since CryoFlask uses the chemical substance to provide the cooling effect without refrigeration, it reduces the need for an electrical or mechanical cooling system, and this reduces in energy savings. Other than that, our CryoFlask will also become useful, especially during outdoor activities or emergency situations happens. For example, a CryoFlask that stores cold water can be used to provide cold water for immediate cooling to wounds, burns, or other injuries in emergencies. It can also be used to keep beverages cold in hot climates or heat waves to prevent dehydration or heat-related illnesses, and also to provide cold water for at least after strenuous exercise under hot weather. Lastly, which is the most important thing, compared to traditional cooling methods, it offers an affordable alternative for maintaining the temperature of cold water. This would be beneficial where refrigeration is not available or costly. For your information, now I will present the cost for CryoFlask. 3 ringgit 60 cents for 45 gram ammonium chloride, 5 cents for zipper lock bag, 60 cents for polystyrene beads, 50 cents for aluminum foil. Totally, it only costs 4 ringgit 75 cents and successfully reached the purpose of low cost. Thank you. Last but not least, we discussed some suggestions for improvement. Firstly, we can enhance the insulation of the flask by adding cotton wool in the polystyrene beads layer, so that the rate of transferring heat to the cooling area will be lower. Besides that, we can add on a temperature sensor to detect the temperature of the water. We can also add in an activation system. This is easier the user to activate the chemical, which is ammonium chloride and water, by using a switch or a lever.